Hello 108 students, welcome back to section 3.2. Mr. McHugh here with you. Going to tackle page 2 on this video, and now we're going to try a problem here for objective 3, and they're going to challenge us and say if you are given a slope, remember M is slope and an ordered pair, x sub 1 comma y sub 1, could you graph this line? And the answer is yes. And the reason why is because given any point, not just the y-intercept, but any point on the line, execute the slope, which is rise over run. You go from one corner of the step up to the next. And think of those steps I drew in the last video. Okay, so here's the steps. Number 1, plot the point that they give you. Okay, this one happens to be 0, negative 4. It's the y-intercept. Remember, every point you start at 0, 0, the origin. X is 0, so you do not move horizontally. You drop down negative 4 and you put your anchor point. Okay, I use a lot of different terminologies to help you here. Now the book's not going to call it the anchor point, it's called the y-intercept, but that's where you're going to start your graph. You need 2 points to determine a line. You've gotten 1. Now execute the slope, rise over run. Rise is what class? Say this over and over again. Vertical change over the horizontal change. It's written as a fraction. How about this? Side note, what happens if they tell you the slope of a problem is 5? What's that rise over run? Well, how about this? Every whole number can be written as 5 divided by 1. Is it equivalent? Yes. So every whole number you write as an improper fraction and you've got your rise over run. Okay, that's just a little sidebar discussion. Now what I want you to do is go back to your anchor point, 0, 4. Your slope is 2/3. Positive 2, positive 3. So up in the numerator is the y, the vertical change. You go up 2 units. Think of this as a turning point. Now I did not put a dot there. That's just a temporary turning point, your pivot point, and now go 3 units. 1, 2, 3, and now you are on a second point on the line. Now that's all you need. Now that happens to be what? Can you tell me what that is by any chance? Looks like it's what? 3, negative 2. 3, negative 2 is a point. 2 points determine a line. Go ahead and use your linear graphing tool. Snap first on this one and 0, negative 4. Don't forget that graphing tool is on your tool palette and it's got a line and 2 dots on it. You click on it, snap on the first point. As you move your cursor around, make sure you enlarge the button. By the way, I forgot to say that in the last suggestion. Enlarge it. Make sure it's big so you can count the grid lines. Get the second point, snap it down, and you'll have your line. Now, I want to challenge you here real quick. I want to propose that this problem starts with 3, negative 2. Okay, now this is just to get this concept down. It doesn't have to be the y-intercept. Any point on the line, can you execute the slope of up 2 over 3? So I go up 2 units to pivot point. A positive 3 means go to the right. 1, 2, 3, and lo and behold, look where I'm at. Actually, that would be what class? Can you name that for me? Hopefully you said x-intercept. What was that ordered pair? Looks like it's what? 6, 0. Okay, now, my challenge for you is, if I ask you to do this one more time, you went from here, you went up like the steps, up 2 over 3. Could you do it again? Could you go up 2 units and over 3? I got to extend my graph here. Up 2, there's the pivot point, over 3, 1, 2, 3. And the answer is yes. This ordered pair would be what? 9, this is 6, 7, 8, 9, 9, 2. Look at the stepping stones, up, over. Now the question is, what if I asked you to learn a concept called reverse slope? And what I mean by this is take this original point, and how could you get back down here to the y-intercept? And I want you to think of reverse slope as taking the slope and asking yourself, is negative 2 divided by negative 3 equivalent to 2/3? And the answer is yes, because a negative divided by negative is a positive. So now execute the slope of negative 2/3. Go down 2 units, 1, 2, pivot point, go back 3, 1, 2, 3, and voila, you've hit it. Okay, that's called reverse slope. Now that's something the book's not going to talk about, but you should feel comfortable to do that. Okay, we got to keep moving here. That's given a point and a slope. You can graph them. Next objective is, let's go back and visit those 2 special cases, a horizontal and a vertical line. Example 3a is y equals 2. I think we graphed this before. Find it on the y-axis. Remember the guideline? Draw the point, anchor point, draw a line through the point and perpendicular to the axis, which forms 90 degrees. You would draw the horizontal line. And now the question is, what's the slope? What is m? You need 2 points to determine a line. You got 0, 2. I choose another line on there. I just went over 3 units on the x, and I called it 3, 2. And then I executed a slope. Rise over run. Slope was rise over run. So I took the y coordinates and I took 2 minus 2. And I got 0. I took the x coordinates, which is horizontal, and I took 3 minus 0, and I got 3, and I got 0 divided by 3, and I got 0. So every horizontal line you're going to ever graph, the slope of it is 0. Now you can memorize that. Horizontal line, slope equals 0. If you forget how to do it, recreate what I just did here, pick another point on that horizontal line, calculate the slope. Remember, you could also do the vertical, you could put the ordered pairs vertically and subtract them like I was doing before if you like. Okay, now what happens if you have a vertical line? Now let's watch this. Let's pick an example. X equals -1. I think we graphed this before. Here's the origin. Come over here to -1, draw a line through the point perpendicular to the axis that it's on, causes you to draw the vertical line, and now we got to figure out the slope. Now pick another point on the line. I went up 2 units on the y-axis. I choose this. It doesn't matter what you pick. This would be -1, 2. Okay, -1, 2, -1, 0. Calculate the slope. Change in the y-axis. I went this way. I subtracted 0, 2. You also could do 2, 0 if you like my new technique of going vertically down. And then you could do -1 minus a -1, or you could go the other way in case it just doesn't matter. -1 minus -1 is going to be the same thing. And you're going to come up with 2 over what? Oh, what's your math there? Turn into addition plus minus, you get 0. Anything divided by 0 equals what, class? Another way to remember it, when the 0 is under the line, I had a student tell me this, it's undefined. When the 0 is under the line, it's undefined. Why is that? Because, here's an example, 6 divided by 2 equals 3. Take the quotient, multiplied by the denominator, 3 times 2 equals 6. What happens over here? You put, if you thought this was 0, and if that was your mistake, 0 times 0 would be what? 0. You does not equal 2. Put another number in. Put 1 in. 1 times 0 equals what? 0. In fact, any number times 0 equals 0. You can never get that 2 in the numerator. That's why it's undefined. Okay, now let's wrap this up here. Last comment here, when you've got a positive slope such as that plus 2 over plus 3, rise over run, up over. This is a positive slope, so when you look at it from left to right, if it's going up, from left to right, if it's going up, it's a positive slope. If you look at a line from left to right and it's going down, it's going to be a negative slope. Okay, we'll be doing more examples of that. You can think of -2, 3. If you start here, you went down 2 units over 3, down 2 over 3. That would cause a negative slope. Okay, hey, we've wrapped up page 2 here. I will see you for page 3, and we'll be finishing up 3.2 when we do there. Okay, I'll say goodbye for now, and I'll see you on page 3. Okay, bye.